In Chapter 13b on hurricanes, we will check the stages of development of a hurricane. Going back to that business about a tropical wave, initially you have what's called a tropical disturbance, which is, maybe an easterly wave or a tropical wave, some sort of a cluster of thunderstorms, as we discussed earlier. When that tropical disturbance gets better organized, when the winds reach sustained speed of between 23 and 39 miles an hour, it's called a tropical depression. No, it's not when you had one too many of those drinks with the funny umbrellas in it. It's not a tropical depression. Ha ha. Okay, bad joke. Then you start to get several closed isobars appearing around the center, just like on a surface weather map. A tropical storm is when the isobars are packed more tightly together, and the wind speeds are around no less than 40 miles an hour, but no more than 74 miles an hour. Then it's a tropical storm, and it gets a name on the so-called list. We'll talk more about that list of names a little bit later. And then when the maximum sustained winds exceed 74 miles an hour, it is called a hurricane. We'll talk later on about the classification system for hurricanes depending on the wind strength. So it goes tropical disturbance, tropical depression, tropical storm, and hurricane. This visible satellite image shows 4 tropical systems, each in a different stage of development. So here's a tropical disturbance, here's a tropical depression, here's a hurricane, and this probably was a hurricane up here, but now it's a tropical storm. So you can see that. The actual path of a hurricane may vary quite a lot depending on a whole lot of factors. The structure of the storm, interaction with its environment, all kinds of things. But generally, they start out moving from east to west, and then they turn to move more northwestward, then move northward around the western edge of the subtropical high pressure system, and then go far enough to the north to be caught up by the westerlies. That's a general pattern of movement of hurricanes in the western North Atlantic. They tend not to form in the tropical South Atlantic, where the water is colder and the wind shear is greater. But guess what? This is a picture from your book, figure 13.14. An extremely rare tropical cyclone that developed in the South Atlantic off the coast of Brazil in March of 2004. This is extraordinary. This March 2004 tropical cyclone in the South Atlantic, adjacent to Brazil, was the first one in the entire history that we've been using satellites to monitor the South Atlantic, which has only been several decades. So this was quite extraordinary. Figure 13.12 shows you the paths of tropical cyclones in a 20-year period from 1985 to 2005. And you can really get a feel for what part of the world they occur in. And there's that one lonely line right there off the coast of Brazil in March of 2004. Now, they rarely hit the west coast of the U.S. because we have colder water coming down from the Gulf of Alaska. That's the California current we learned about. Now, the remnants of tropical cyclones, if they get into the southwestern United States, can bring late summer rains to the region. And of course, that's always critical here for our crops in August and September. They tend to weaken before they hit Hawaii, but Hawaii occasionally does get hit with a hurricane. Hurricane Iwa did damage to parts of Hawaii in November of 1982. Hurricane Iniki hit the island of Kauai in September of 1992, as shown by the image here showing damage on Kauai. Iniki in 1992. Here are the paths that are taken by some hurricanes, and they, as you can see, are not always consistent. They're quite erratic, especially if you note the path of Hurricane Nora in 1997 and the path of Hurricane John in 2006. Those are West Coast hurricanes which gave a threat of late summer rains to very sensitive crops here in the southwestern United States. North Atlantic hurricanes often take one of 3 paths. They either go west toward the Caribbean, Central America, Mexico, or the Gulf of Mexico, or they go northwestward toward the south or southeastern United States, or they can come close to the United States, turn northward, paralleling the U.S. coast and going out over the open water up in the North Atlantic. Now, this graphic shows you likely paths in August, September, and October, according to research, of western North Atlantic hurricanes. Now, let's talk a little bit about the naming of hurricanes adjacent to the Americas. Take a little mystery out of that for you. Initially, These tropical cyclones were identified by their latitude and longitude, but that became very, very, very confusing. Next, the military phonetic alphabet was used. Alpha, Bravo, Charlie, and so on. From 1953 to 1977, they were given female names in alphabetical order, but then in the interest of political correctness, in 1978 in the Northeastern Pacific, alternate male and female names have been used since then, and the same system was started in the Western Atlantic in 1979. Now, if the National Hurricane Center runs out of names in a particular season, then they use the Greek alphabet to continue naming the storms, like Alpha, Beta, Gamma, and so on. This actually happened in the Atlantic season of 2005, when they went all the way to Zeta, which actually formed in January of 2006. That was quite extraordinary. You can look at table 13.1 or page 376 in your textbook, but here is the National Hurricane Center. I know part of this is off the screen, but you can look at it later on. This is the actual National Hurricane Center website showing you the names of the hurricanes. Now let's talk about the kinds of damage you can get with a hurricane. Winds, flooding, and storm surge. Winds are always going to be strongest on the right-hand side of the hurricane relative to the forward path of motion. That's because the forward motion adds to the wind speeds on the right side and actually subtracts from the wind speeds on the left side of the hurricane. So this is a little graphic of the east coast of the U.S., and you can see that if the hurricane is moving forward at 25 miles an hour, the maximum winds on the right-hand side are stronger than the maximum sustained winds on the left-hand side, relative to the forward path of motion. This is a little graphic about storm surge, and I highly recommend that you read the Extreme Weather Watch box on page 379 regarding storm surges. So here you are, you've worked the same job for 30 years, you had the party, they gave you the gold watch, you built your, version of Margaritaville on some barrier island off the coast of Texas or North Carolina, and then a hurricane comes and the storm surge comes in because of the wind and high water, and it's bye-bye Margaritaville. So there are vulnerable parts of our coastline along the United States due to storm surge. Now let's talk about how they rank hurricanes with respect to strength. There was a guy named Herbert Saffer. He was a structural engineer, and a guy named Bob Simpson was the director of the National Hurricane Center. I know that Herbert Saffer is deceased now about 6 years. I'm not sure if Bob Simpson is alive still, but Dr. Simpson would be in his 90s if he's still living. In 1969, these guys got together for coffee, presumably, and they developed a scale to give people an idea of the potential damage based on projected wind speeds and also the storm surge. So they came up with the Saffer-Simpson hurricane category scale. Hurricanes of Category 3 or higher are considered to be major hurricanes. In the Western Pacific, typhoons Category 3 or higher are considered to be super typhoons. So anything 3 or better means that these things are very, very destructive storms. This is a table from your book, Table 13.2, which is in fact the Saffer-Simpson Hurricane Damage Potential Scale, and you can read this on your own and study it in greater detail. This figure from your book shows the number of hurricanes by each category that have made landfall along the United States coastline, to our knowledge, from 1900 to 2007. All the hurricanes shown struck either the Gulf or Atlantic coasts. Categories 3, 4, and 5, remember, are considered major hurricanes. So it's interesting that there are more Category 3 than there are Category 2 storms. I find that particularly interesting on this graphic. Although storm surge and wind damage are devastating, a hurricane that makes landfall can produce swarms of small, short-lived tornadoes in the northeastern quadrant of the storm. That adds to the wind damage. Hurricane Andrew in 1992 hitting eastern Florida is certainly a big example of that. In the 30 years or so before Hurricane Katrina, the death toll from U.S. hurricanes and tropical storms was relatively low, about 50 people annually. Then Katrina really busted the averages because nearly 1,800 people died in Katrina. With Katrina, although the evacuation warnings were issued, many chose not to leave their homes or did not have the means to leave their homes because there's a lot of poverty in New Orleans. That did, in fact, contribute to a death toll of around 1,500, actually ended up being closer to 1,800. Hurricanes can do lots of things. They can contaminate drinking water. They can contaminate food supplies. They can cause power outages, disrupt phone service, and cause impassable roads. Obviously, a problem for ship navigation, all kinds of devastation that hurricanes can cause. Hurricanes offshore can cause huge waves that can drown people who actually get too close to the shoreline. You know, hurricanes coming, watch the big waves. Maybe the hurricane doesn't make landfall, but people are vulnerable if they go to the beach to watch the big waves. There was an extraordinary record-setting hurricane season in 2004 and also in the summer of 2005. This shows you the paths of those hurricanes. And in 2004 alone, 4 hurricanes impacted Florida, which is quite extraordinary. In 2005, there were 27 named storms, which was the most in a single season since we've been keeping records on these sorts of things. This ends Chapter 13, Part B.